Today is one of those days where you'll never come up to me and say, I don't understand how to do this, because, I don't know, oh yeah, maybe not. Oh yeah, sure. Right on top surface area, please. And I believe this is total surface area. I don't know if they asked you lateral surface area. Oh, they do ask you lateral surface area. So I suppose we have to define this. We've got total surface area. And we have what's called lateral surface area. What is the difference between those two? Well, total surface area is just like I said. It is the area of all, underline all, sides added together. Lateral surface area is the area of all sides, but the bases. And we will, well, I guess we'll explain it now. Okay, that means this. If you have a rectangular prism, school sometimes feels like a rectangular prism. Well, I can't do it. Switch that. Most of you play this. If I have a if I have a triangular prism, if you are looking for lateral surface area, I suppose let's make some easy. Let's put some easy numbers on this. The beauty of being a teacher is you can always. Let's make it a right triangle too. Let's make this 10, 12. Oh, what, 8? Should I give you the hypotenuse? Sure, let's make the hypotenuse 13. Huh. Okay. Total surface area means you'd have to find the area of all the sides of this, which is how many? How many sides in a triangular prism? Anybody? Going once, going twice, 3 times, 4 times, 5 times. Somebody give me something out there to work with here. Elijah? 9. Huh? 9 total sides. Where do you get the other 4? What's that? Is your head stuffed up? Because it sounds like it. What? No, I'm just saying. Here's my same triangular prism, except it's not a right triangle. How many sides are there? Elijah? 5 sides. You'd have to find the area of all the 5 sides and add it together, which would be, should we do that? Yes, let's do that. Why not? By the way, well, no, let's just do it. What's the area of the triangle? Can we do that in our heads? 1/2 base times height, 1/2 base times height, half of 120. Jade? Alright, we got 60 whatever it is, inches squared. And believe it or not, there's another identical triangle on that side, is there not? What's its area going to be? Anybody? Thank you, you did catch that. So I got those 2 triangles. We then have this rectangle here that is 13 by 8. I should have told me, I'm running out of room. Anybody 13 by 8 in your head? Go on. I'm somewhat of a failure. 104. What's the bottom rectangle? 12 by 8, correct? 12 times 8 is 96. And this left side rectangle is 10 by 8. Maybe somebody can do 10 by 8. Anybody? 80. Wow. So the total surface area is going to be 60 plus 60 plus 104 plus 96 plus 80 all added together. That's not anything new, we've done that before. You wanna know what it is actually? Well, that'd be tough. Oh look, 120 plus 80 is 200. 200 plus 104 is 304. 304 plus 96? How does that work out? 400 inches squared. How is that different than lateral surface area? Lateral surface area is the same exact thing, except you don't count the bases. We really call it the area of the sides, but in order to do lateral surface area, you must know what the bases are. And when you think of bases of three-dimensional shapes, you are obviously going to think of the loaf of bread theory. What if this was a loaf of bread? What shape would it be? You'd cut that, you put in the toaster that you keep getting the same shape. It would be the triangles. So the lateral surface area is going to be this same thing, except you don't count the two triangles. It's going to be that 104. It's going to be that 80, and it's going to be that 96. Wait, did I do that wrong? Is this really 400, or did I just make that up? Because if you add all this together, you get what? 0, 1, 18, 280 inches squared. Oh yeah, plus the other 120 gives you that. Now, some of you are saying, sir, is there an easier way to do all this?
Is there an easier way to do all this?
No. So we just move on. Actually, for this there is. If you can think this far in advance, there's actually a formula for lateral surface area that looks like this. Lateral surface area equals the perimeter of the base times the height of the shape. Lateral surface area, LSA equals perimeter of base times the height. I would show you how that works with this. First of all, what's the base of this shape again? It's a triangle. So if you find the perimeter of the triangle, what's the perimeter of this triangle? 10 plus 12 plus 13, which happens to be 35, right? You multiply that by the height of the shape, which is what? 8. 35 times 8 is going to give you that 280 right there. That's about as easy as I can make it. So you wouldn't have had to do each shape separately. You can use that formula, but you can certainly just use all of those shapes there. Now, with that being said, by the way, when would you use lateral surface area? We've talked about this before. If you were trying to paint the walls of my classroom, okay, you don't paint the ceiling, you don't paint the floor, you just paint the walls. That is the lateral surface area, is the base and the whatever. Although in a rectangular prism, anything can be the base, correct? Because anything can be the loaf of bread. Are you with me on that? You know, if this were my shape, and you were trying to make pieces for toast, yeah, you could cut it like this and keep getting this square, but you keep getting squares, but you could also slice it like this and keep getting this big rectangle, or you can slice it up and down like this. That's why, you know, volume of this is up here. Here we go. Now, along those same lines, we're going to do this. Draw yourself a nice little cylinder. The surface area of a cylinder has its own little formula here. And you're going to want to write this down. Surface area of a cylinder. By the way, what shape is the base of a cylinder? Circle, right? So, and how many circles do you have? Huh? How many circles are in a cylinder? 2 of them, right? So you have 2, what's the formula for the area of a circle? Pi r squared, 2 circles, the area of 2 circles, plus now you have to do the area of the label of the can, which is the circumference of the circle, which is where pi times diameter comes from, times height. 2 pi r squared plus pi times diameter times height. So no one can ever tell me they don't know how to do the surface area of a cylinder because I've given you the formula. Let's put it into practice here. Somebody tell me what's the diameter of my can that I drew there? Give me something. Jaden, give me a number. 3. You only need these 2 dimensions to find the surface area. What's the height of my can, Elijah? 17.5. So you just plug those numbers in your formula, and this is what I need to see if you're trying to appease the teacher. 2 times pi times the radius squared, 3 squared. You are going to add that to, oh wait, sorry, this isn't radius, is it? What is the radius? Thank you, Jaden. If the diameter is 3, what's the radius, Jaden? 1.5. Plus that, I'm going to add pi times diameter, which is 3, times the height, which is 17.5. Thank you for that, Elijah. Now, can I take 2 times 1.5 and make it 3 before I square it? Yes or no? Who votes yes? Really? Why not? Isabel? Order of operations say you have to do exponents first. So you're going to have to do 1.5 times 1.5, which is what? 2.25. Multiply that by 2, you get 4.5 pi's plus 3 times 17.5. Elijah, you better be able to do that in your head because you came up with it. What is it, Elijah? 52.5. Oh, good. 52.5. Now, fortunately, the book will probably tell you to leave in terms of pi. That means you don't have to multiply by 3.14. Can I put these together? If I have 4.5 pi's, can I add 52.5 pi's to it? Yes, I can. As long as there's a little pi, they're both pi's, you can put them together. How many total pi's do I have?
57.
57 pi's is my surface area. So that would be whatever it is, inches squared, or whatever my area is. 57 pi's inches squared. That is just. Open your beloved books to page 570. Look at the top where it says example number 3. See there where it talks about Hector? Hector wanting to paint the exterior walls of a shed says to find the lateral surface area of the shed. Notice what they say that Hector can do. Rather than adding all the sides together of the areas, Hector can find the areas of the 4 walls by multiplying the perimeter of the shed by its height. So Hector has this little shed. Now I don't know why Hector's not painting the little gable part of it, but he's not, apparently, according to the book. You've got this little thing here, and it's got a little roof on it. And it said he just wants to paint the walls. I think I drew this backwards, didn't I? Hector's shed looked like this, sorry. I'm not used to drawing it this way, but we'll do it anyways. Alright, this was what, 10 and 8? And it was 7 feet tall. Apparently you're not painting this because it looks like it's a different shade already. So you're just painting the walls. So they said all Hector needs to do is find the perimeter of this base, which is 8 plus 10 plus this 8 over here you can't see, plus that 10 over there you can't see, which gives you 36, multiplied by the height, which was 7 feet tall, and in your head you came up with what? 252? Did Hector have enough paint? Now, look at letter E. I'll entertain this notion here. We didn't talk about this, but you being infinitely wise seventh graders should be able to figure that out. What would the lateral surface area of a can be? 40 feet by 30 feet. That's a big can, by the way. What would you do to find the lateral surface area of that? By the way, that'd be the area of the label. What do you need to not? If you look at your surface area formula, what don't you have to do? We might have talked about that. We're not including the area of the bases, Mitch, which is what?
The area of the base, that would be the top,
And,
bottom.
yeah, the two circles. So all you have to do is find the surface area of the sides, which the formula for the area of the sides is about pi times diameter times height. Pi times diameter is the circumference of this circle, and the height is right there. So it would be 40, which is the diameter, times 30 times pi. And did it say to leave in terms of pi? Oh, it didn't. It said to use 3.14 pi. That's enough of that. All right. For tomorrow, I think we shall do lesson 85. What is the odds? 85 odds.